acting on the M1 block. So here this is the M1 block. T minus 0 Newton. So here in right side there is, in left side, here left side there is no force acting on the block M1. So therefore resultant force here M1A equal to T. So this is equation number 1. Now free body diagram of M2 block. Second one, free body diagram of M2 block. So here this is the M2 block. So here in right side there is a pulling force F, in left side tension force acting on the block. So now acceleration of the block is in pulling force direction. So therefore resultant force acting on the block Fr equal to M2 block is F minus T. So therefore according to Newton's second law, M2A equal to F minus T. So this is equation number 2. Now these two equations are adding, we get acceleration. So here acceleration of this system. So here these two equations are adding. So equation number 1, that is M1A equal to T. Equation number 2, M2A equal to F minus T. So equation 1 and equation 2 are adding. We get here minus T plus T cancel. A into M1 plus M2 equal to F. So therefore acceleration A equal to F by M1 plus M2. So this is the acceleration of this system. Now we can find out tension in this string. Now we can find out tension in the string. So now from equation 1, here T equal to M1A. Here T equal to M1 into, here A means F by M1 plus M2. So this is the tension in the string. Now in the second case, 3 blocks are arranged in the same smooth horizontal surface by connecting a string. Then we can find out the acceleration of the system and the tension between M1 and M2 block and M2 and M3 block. Next case is three blocks are connected by a string. So here 3 blocks of masses M1 and M2 and M3. These 3 blocks are laying in laying on a smooth horizontal force, then a pulling force is acting on the block M3. Now these three blocks are connected by a same string, then these three blocks are treated as one system. So the acceleration of the same system is direction of the force. Now we can find out the acceleration of the system, and the tension is developed in between M1 and M2 block is M1 and M2 block is T1. The tension between M2 and M3 block is T2. Now we can find out the T1 and T2. Okay. Now free body diagram of M3. First one, free body diagram of M3 block. So now this is the M3 block. So here right side pulling force is acting on the M3 block, left side tensional force T2, but acceleration of the block is towards right side. So resultant force Fr equal to F minus T2. So according to Newton's second law, Fr equal to ma, that is M3a equal to F minus T2. This is equation number 1. Now free body diagram of M2. Now free body diagram of M2. Free body diagram of M2. So here this is the M2 block. Tensional force T2 is acting right side. Tensional force T1 is acting left side, but acceleration acting on the M2 block is right side. So therefore resultant force Fr equal to T2 minus T1. So here Fr means according to Newton's second law F equal to ma. So M2a equal to T2 minus T1. This is equation number 2. Now free body diagram of M1. Free body diagram of M1. So in this situation, this is M1 block. Here tensional force acting only right side, that is T1, but acceleration of the block is A, towards right side. So therefore according to Newton's second law, Fr equal to T1. So here M1A equal to T1. So this is equation number 1. Now we can find out the acceleration of this system. These three equations are adding. Now acceleration of this system. These three equations are adding. Equation 1 plus equation 2 plus equation 3. So here equation 1 means M3a equal to F minus T2, and equation 2 is M2a equal to T2 minus T1, and equation 3 is M1a equal to T1. So these equations are adding minus T2 plus T2 minus T1 plus T1. So therefore A into M1 plus M2 plus M3 is equal to F. Now acceleration of the system A equal to F by M1 plus M2 plus M3. This is the acceleration of the system. Now we can find out tension in between M2 and M1 block and M3 and M2 block. Now tensional force between M1 and M2 block. Now from equation 3 we get M1A equal to T1. So here T1 equal to M1 into, here acceleration is F by M1 plus M2 plus M3. So this is the tensional force between M1 and M2 block. Now we can find out tensional force between M2 and M3 block. M2 and M3 block. Next one, tensional force between M2 and M3 block. So from equation 2 we get, from equation 2, that is M2A equal to T2 minus T1. So in this situation T2 equal to M2A plus T1. We know that from equation 3 T1 equal to M3A. T1 equal to M3A. Sorry. T1 equal to M1A. So therefore T2 equal to M2A plus M1A. So T2 equal to M1 plus M2 into A. So therefore M1 plus M2 into, here A means F bar, M1 plus M2 plus M3. So this is the tensional force in between M2 and M3 block. Okay, thank you. Good morning everyone. Today discuss about Atwood mission. So Atwood mission is one of the arrangement to determine the acceleration due to gravity at this place. So here in this situation, two blocks of masses M1 and M2 are connected by a string passing over a smooth frictionless pulley. So this string is massless and inextensible. So this arrangement is called as Atwood mission. Now we can find out acceleration of this system and tension in this string. So here tensional force acting on the upward direction and weights in vertically downward directions. So in this case M1 block is larger than comparable to the M2 block. So now tensional force acting on the M1 block vertically upwards, weight of the M1 blocks vertically downwards, and here another block, weight of the second block weight vertically downwards, tensional force vertically upwards. Now these two blocks are freely suddenly released, then it is M1 blocks vertically downward direction but M2 blocks vertically upward direction. Now acceleration of the M1 blocks vertically downward direction, acceleration of the M2 block is vertically upward direction. So these two blocks are treated as one system. Then we can find out the acceleration of that system and we can find out the tension in this string. Now, free body diagrams of M1 block. First of all, free body diagram of M1 block. So here, this is the M1 block. Here weight is vertically downward direction, but tensional force acting vertically upwards. Acceleration of the M1 block is vertically downward direction. So therefore, resultant force acting on the M1 block F equal to M1G minus T. According to Newton's second law, M1A equal to M1G minus T. This is equation number 1. Now, free body diagram of M2 block. Free body diagram of M2 block. So here, this is the M2 block. Weight vertically downwards, tensional force vertically upwards. Now acceleration of the M2 block is vertically upward direction. So resultant force acting on the M2 block is Fr equal to T minus M2G. According to Newton's second law, M2A equal to T minus M2G. So this is equation number 1. Now we can find out the acceleration of the system. These two equations are adding. Now we can find out the acceleration of this system. Adding equation 1 and 2, we get acceleration. So here equation 1 is M1A equal to M1G minus T. Equation 2, M2A equal to T minus M2G. So here minus T plus T cancel. So therefore A into M1 plus M2 is equal to M1 minus M2 into G. Now acceleration A equal to M1 minus M2 G by M1 plus M2. So this is the acceleration of this system. Now we can find out tension in this string. Tension in the string. Now, from equation 2, we get M2A equal to T minus M2G. So therefore T equal to M2A plus M2G. So here T equal to M2 common, this is the G plus A. So T equal to M2 into G plus, here acceleration of this system is M1 minus M2 into G by M1 plus M2. So here G also common. So here T equal to M2G into So here m1 plus m2 plus m1 minus m2 by here LCM is m1 plus m1. Here minus m2 plus m2 cancel. So P equal to m2g into 2m1 by m1 plus m2. So now P equal to 2m1 and 2g by m1 plus m2. This is a tension in the string invertible equation. Now this tension in the string is in terms of weights of the two blocks. Now tension in the string in terms of weights. So here W1 means weight of the M1 block, W2 is weight of the M2 block. From tensional force, here T equal to 2m1 m2g by m1 plus m2. And now this equation is multiplying g by g term. So now T equal to 2m1 m2 g square by m1g plus m2g. So here 2 into m1g into m2g but m1g plus m2g. So therefore tensional force P equal to 2m1g means 2w1 into m2g means w2 by w1 plus w2. So this is the tension in the string in terms of weights. Thank you.